STEM adventure. Revision notes. OCR A-level physics. Foundations of physics. The single most important topic to be on top of and to have memorized perfectly are units and multiples. These prefixes will be used in all questions, and your ability to convert these units will have a massive impact on your score. These must be memorized. The units we use are all formed around a limited number of base units. You only need to know these 6. All other units are derived from these base units. So for example, the unit J joules can be broken into its base units. To do this, use the equations available to you in the data book. So joules are a unit of work. So we can use the work equation, which is equal to force times distance, to get closer to the base units. Force is newtons and distance is meters. So joules are Newton meters. We can then further break down force, which is mass times acceleration, into kilograms and meters per second squared. So joules can be broken down into meters squared, kilograms and seconds to the -2. The difference between vectors and scalars needs to be understood. Vectors having both magnitude and direction, and scalars only magnitude. The reason remembering which quantities are vectors is important is so you can set their value correctly. Positive for one direction and negative for the opposite direction. This can be critical to a lot of questions, including those involving velocity, acceleration and momentum. Don't forget that the databook has a lot of mathematical equations and functions that might be useful. Being on top of all these is critical. Graph plotting and interpretation questions will almost always come up. So remember the key things. The best fit line needs to go as close to all points as possible and through all error bars. Also remember the best fit line doesn't have to be straight. We are using a straight example here so we can show error gradients, etc. We can draw a maximum gradient and a minimum gradient, and these also need to go through the error bars. And use these to calculate the error in the gradient. Tables should be drawn with these rules implemented, so ensuring that the same number of decimal points are used in each column of data. These methods are also useful for your PAGs. The difference between accurate and precise needs to be understood. Accurate means close to the real value, so small systematic error. Precise means measured with a small amount of random error. The table shows examples of where these random or systematic errors might occur. Questions where you are asked to calculate errors are common, and we need to remember the different types of errors. Also how to work out the overall error for different types of calculations. So remember, for additions or subtractions, we must add the absolute errors. And for multiplication and division, we must add the relative or percentage errors. Lots to memorize there before you move on. Finally, how to add vectors is required, but only simple 2D additions will be necessary. And how to calculate the components of vectors. This is especially useful in momentum and free body questions. Luckily, these details are in the data book. Lots to get on top of, and many are critical to your ability to score high marks in calculation questions. Remember, all our resources are available on our website, including revision notes, flashcards, multiple choice questions, and past paper questions.